evolution of STP. So there are different versions of STP. Actually, STP by itself is open standard. Even other vendors has STP. Um, and many professionals generically use STP to refer to the various implementations of spanning tree, such as rapid spanning tree and multiple spanning tree protocol. So these are other variations of the STP, rapid spanning tree and then MSTP. The latest IEEE documentation of STP says STP in-house now superseded by the RSTP, and the IEEE uses STP to refer to the original implementation of the spanning tree, and RSTP to describe the version of spanning tree specified in the IEEE 802.1d 2004. Because the two protocols share much of the same terminology and methods for the loop-free path, the primary focus will be on the current standard in the Cisco proprietary implementation of STP and RSTP. Cisco switches running iOS 15 or later run PVST Plus by default. This version incorporates many of the specifications of IEEE 802.1d 2004, such as the alternate ports in place of the former non-designated ports. Switches must be explicitly configured for rapid spanning tree mode in order to run the rapid spanning tree protocol. These are the different variety of STP. So we have the STP, and then we have the PVST Plus. I'll demonstrate. I'll have a separate demonstration, must-watch video for the STP demonstration of how to configure PVST Plus. Actually, how to set up a root bridge, and also have like an overview of so far the concept of STP and also even the PVST Plus. So, and then another variety is 802.1d 2004. This is the updated version of the STP. Then we have the RSTP. So like if you recall, in STP, it has like around blocking for 20 seconds, listening for 15, learning for 15. For rapid, it's much faster. So like all in all, like in STP, there's like 50 seconds, but in RSTP, it's less. I think only 15 to 20 seconds. That's why it's called as rapid. So it's much faster as compared to the STP. So we have rapid PVST, also much faster as compared to the PVST. In the port state, like blocking, listening, learning, forwarding, that's the same for STP and PVST plus. Okay. Then we also have MSTP and MST. Okay. By the way, PVST plus and our rapid PVST plus are Cisco proprietary. Okay. Only find it in Cisco switches. So RSTP under IEEE 802.1W supersedes original 802.1D while retaining backward compatibility. The 802.1W STP terminology remains primarily the same as the original 802.1D STP terminology, and most parameters have been left unchanged. Users that are familiar with the original STP standard can easily configure RSTP, and the same spanning tree algorithm is used for both STP and RSTP to determine port roles and topology. RSTP increases the speed of the recalculation of the spanning tree when the layer 2 network topology changes, and RSTP can achieve much faster convergence in a properly configured network, sometimes in as little as few hundreds milliseconds. If a port is configured to be alternate port, it can immediately change to a forwarding state without waiting for the network to converge. Then, if a port is on a switch is connected to an end device, to the PC, it usually doesn't need to participate in the STP process. If you look into the STP, it's like a relationship between switches. So it should only be like a process in connection between switches. So in a way, for a way to like lessen the process of those ports of the switch connected to the end devices, we may set up these two, port fast and BPDU guard. So in port fast, what happens, say for example, if you have a switch and there's like an end device connected, if you remember in the port state, it needs to like, before a link to be up, it needs to wait like around 50 seconds, right? It needs to go like to blocking, listening, learning, forwarding. So in port fast, so if you set this port here where an end device, a PC is connected, so it will not undergo with that port state. Okay, it's as if it's like you disable STP here. So automatically it will go up. So that's a good thing with port fast. And then with BPDU guard, Usually BPDUs are sent in all ports, right? So like for example, if I have another switch here, well, I need to forward the switches need to forward the PPDU for this port going here, right? Because this switch needs it, but not the end device. End device do not need the PBDU. So in a way, for this switch not to forward the PBDU to this PC, you so set this port also. Example, this is port 1. You also set this port 1 with BPDU guard. So in a way, um, the resources of your end devices are not interrupted by the PBDU, bridge protocol data unit, sent by the switches. And to sum it up for this module, redundant paths in a switch Ethernet network may cause both physical and logical layer 2 loops. A layer 2 loop can result in MAC address table instability, link saturation, and high CPU utilization on switches and end devices. STP is a loop prevention network protocols that allow for redundancy while creating a loop-free layer 2 topology. Without STP, layer 2 loops can form, causing broadcast, multicast, and unicast, unknown unicast frames to loop endlessly, bringing down a network. Using the STA, STP builds a loop-free topology in a 4-step process. We elect the root bridge, we elect the root ports, we elect designated, and elect alternate ports. And during STA and STP functions, switches use BPDUs to share information about themselves and their connections. And BPDUs are used to elect root bridge, root port, designated, and alternate. And when the root bridge has been elected for a given spanning tree instance, STA determines the best path to the root bridge from all destinations in the broadcast domain. And the path information, known as the internal root path cost, is determined by the sum of all the individual ports cost along the path from the switch to the root bridge. After the root bridge has been determined by determine the STA algorithm, select the root port. The root port is the port closest to the root bridge in terms of overall cost, which is called the internal root path cost. After each switch selects a root port, switches will select designated, and designated is a port on the segment that has the internal root path cost to the bridge. If a port is not a root port or a designated port, then it becomes an alternate port. Alternate ports and backup ports are in discarding or blocking state to prevent loops. And when a switch has multiple equal cost path to the bridge, the switch will determine a port using the following criteria: the lowest sender bridge ID, then the lowest sender priority, and finally the lowest sender port ID. STP convergence has the hello, the forward delay timer, and the max age timer. And port states are blocking, listening, learning, forwarding, and disabled. In PVST versions of STP, there is a root bridge elected for each spanning tree instance. This makes it possible to have different root bridge for different set of VLANs. STP is often used to refer to the various implementations of spanning trees such as RSTP and MSTP. And RSTP is the evolution of STP that provides faster convergence than STP. RSTP port states are learning, forwarding, and discarding. PVST Plus is a Cisco enhancement of STP that provides a separate spanning tree instance for each VLAN configured in the network. Cisco switches running iOS 15 or later run PVST Plus by default. Rapid PVST Plus is a Cisco enhancement of RSTP that uses PVST Plus and provides separate instance of 802.1W per VLAN. And when a switch port is configured with port fast, the port transitions from blocking to forwarding state immediately. And use port fast on access ports to allow devices connected to these ports, such as DHCP clients, to access the network immediately rather than waiting for STP to converge on each VLAN. And Cisco switches support a feature called BPDU guard, which immediately puts the switch into an error disabled state upon receipt of any BPDU to protect against potential loops. Over the years, Ethernet LANs went from a few interconnected switches that were connected to a single router to a sophisticated hierarchical network design. And depending on the network implementation, layer 2 may include not only the access but also the distribution or even the core layers. And layer 3 routing allows for redundant path and loops in the topology without blocking ports. And for this reason, some environments are transitioning to layer 3 everywhere except where devices connect to the access layer switch. And this ends this module, module 5. I'd like to thank you for listening. Keep safe. Together we learn as well.